Okay, let's look at adding and subtracting these rational expressions. So adding and subtracting fractions is harder than multiplying and dividing them because we can't just go straight across. We have to have a common denominator. So when we add or subtract rational expressions, they are fractions, so we need a common denominator. So my first example, denominator is 2. So I have that common denominator. So there I just go straight across. 5 minus 8 is negative 3. And then I keep my denominator as 2. My second example, I do not have a common denominator, so I want to make one using multiplication. So there I say, okay, well, I can make 3 into 6 by multiplying by 2. And I multiply the numerator and the denominator, which then gives me 7 over 6 minus 7 times 2, 14, 3 times 2, 6. Then I have a common denominator that I made through multiplication. Then I subtract straight across the top, 7 minus 14, negative 7, and I put it over the common denominator. So we are doing actually the same thing with rational expressions, except it looks a lot harder because now you have variables. This section, though, we're just going to deal with when we already have a common denominator. And then on Monday, we will do the non-common denominator, which is a little harder. Okay, so here's our steps. If our problem is subtraction, we want to distribute the minus sign because I'm subtracting more than one term, so I want to distribute that. This one is just addition, so I don't need to worry about that. Step 2, I will find the least common denominator. We'll work on that in the next section. This example already has a common denominator, so we go straight to step 3. So we just add and subtract across the numerator. So here I'm just going straight across, and I'm adding, which means I am just going to combine like terms here. So I have 5x minus 4x gives me an x, and negative 7 plus 5 gives me a negative 2. And then I write that over the common denominator, which is this x squared minus 5x plus 6. And then we're at simplifying these like we did in the last section. Factor, cross out any like factors. Okay, so my numerator is x minus 2. My denominator, it looks like I can probably factor this. Okay, so I put my x's here. 6 is one of those tricky ones. You got 1 and 6, 2 and 5, or sorry, 2 and 3, which both combine to 5 somehow. Okay, but I have a positive 6, which means I need the same sign. Okay, so same sign would be 7 with the 1 and 6, and 5 with the 2 and 3. So I want 2 and 3. So I want same sign, but I want that to be negative, because if I look here, I have a negative in the middle. So negative 2 minus 3 gives me negative 5. Negative 2 times negative 3 gives me positive 6. So that's factored. Then I have x minus 2 over x minus 2, x minus 3, which means I can cancel the x minus 2's out. And I'm left with just an x minus 3 in the bottom. What do I need to put in the top? I do need a 1 in the top. I can't just leave it blank. Okay, so let's look at the next example. This one does have subtraction. So when I get subtraction, here's what I will do is I'll just take this and put this in parentheses and then put the minus sign there. So then it just looks kind of like one of the problems we did in one of the first sections where you're just adding and subtracting polynomials. So that looks like this, 9x plus 7, then minus 5x plus 1, because I'm distributing that minus sign. Then I combine like terms here, so 9x minus 5x gives me 4x. 7 plus 1 gives me 8. And then that's the numerator. Let's go ahead and factor that. I can take a GCF of 4 out of that. And that'll give me 4. And then 4x divided by 4 will give me x. 8 divided by 4 will give me 2. And then I'll put that over my common denominator, which was also x plus 2. And then I get to cancel these x plus 2's out. And I'm left with just a 4. So both of those actually had some nice canceling. I don't know how much time we have for practice problems, but you guys can work on these for about 5 minutes. It should be pretty quick though, and then we'll go over them. Okay, so for the first one, it's subtract. So we're going to take this, I'm going to put a parentheses here, and the minus sign, just going to carry it over here. And really, I just kind of draw the line like that. So then this comes over as y plus 5. And then we distribute the minus. This is minus y, and then plus 8. Then if I combine like terms, y minus y cancels out. So it's just 5 plus 8, which is 13. And then over y minus 2. And you can't do anything with that, so you leave it just like that. All right, second example. I just have one term in both numerators here, so I can just write that as a squared minus 4 over a plus 2. But before I do that, I can factor that. What's that going to factor to? Good, yeah, that's that special one where the middle terms cancel out, so that's a plus 2, a minus 2. Then you write that over the a plus 2, the numerator, or denominator, and they cancel out. So you're left with just a minus 2, and that's your answer. You don't have to put it over 1. Now, if it were in the denominator, you'd have to put a 1 on the top, but since it's in the numerator, you can just leave it. I wouldn't mark it wrong, but you never know with the homework platform. So I don't believe they would, but actually I believe that they probably would on my lab math. So yeah, they might just say, oh, your answer is correct, but it's not fully simplified, you know, that kind of thing. Okay, and then the last one, this is plus. So I'm just going to go ahead and combine like terms. So 7x minus 5x gives me 2x. And 10 minus 6 is positive 4. Can I pull a GCF out of that? 2, yeah. So I can divide a 2 out. So 2 and then 2x divided by 2 is x. 4 divided by 2 is 2. So that gives me 2 times x plus 2. And then that's over x squared minus x minus 30, which I can factor that. To what multiplies the negative 30 and adds to negative 1? Negative 6, positive 5. So x minus 6, x plus 5. So I factored it, but I can't cancel anything, so that's a bummer. But I still need to put it in factored form. And that's it. So when you have the common denominator, it's really not too bad. But on Monday, we'll look at with the common denominator. It does make it a bit more complicated.